Good morning. Now we are ready to deliver some facts regarding absolute space, time, and motion. In our scientific consideration, we mean by the word motion either linear or rotational in a specific frame of reference governed by certain laws. Frame of reference is either inertial or non-inertial. Linear motion is a translational motion in a straight line. Force is responsible for linear acceleration whenever torque is responsible for angular acceleration. The basic ideas of state of rest and uniform motion were studied by many philosophers. According to Aristotle, 384 to 322 BC, a constant force had to be applied on a body so as to keep it in a motion with constant velocity. Later on, Galileo 1564 to 1642 stated that no force is required for a body to move with uniform velocity. This was the opinion of Galileo. Sir Isaac Newton, 1642 to 1727, was the first natural philosopher who formulated the laws differentiating the state of rest and the state of uniform motion. Newton's notion of the space is the notion of the absolute space. The nature of Newton's space is isotropic or rotational invariance and homogeneity, that is homogeneous nature of space is or translational invariance. Any accelerated frame of reference is a non-inertial frame of reference. Is a non-inertial frame of reference. Again, we have to explain it. A system of coordinate axes which defines the position of a particle or an element in two or three-dimensional space is called a frame of reference or reference frame. The essential requirement of a frame of reference is that it should be rigid. The simplest frame of reference is, of course, the familiar Cartesian system of coordinates, in which the position of the particle is specified by the three coordinates x, y, and z along the three perpendicular axes such that their position vectors can be represented by combining the unit vectors with all three coordinate axes or with all three coordinates. That is, vector r can be expressed as x vector I plus y vector j plus z vector k, where vector I, vector j, and vector k are the three unit vectors which may be written as I tuple, j tuple, or k tuple along the three coordinate axes. The velocity of the particle is thus formulated as vector v is equal to ddt of vector r, that is ddt of x with vector I plus ddt of y with vector k plus ddt of z vector k. The acceleration of the particle vector A is given by vector A equals to ddt of vector v, and that can also be denoted by d2 vector r divided by dt square. The origin of the frame of reference may not always be coincident with the position of the observer. The frame of reference must, however, be at rest with respect to the observer. Thanks, and in continuation with this lecture, we shall continue to explain this frame of reference in our next lecture. Thank you.